by Hofmann degradation, or you can say Hofmann rearrangement, or you can say Hofmann bromamide degradation of, or you can also call as Hofmann hypobromite degradation. Here the degradation word is very important, friends. So amide is given to you, we are going to degrade the amines. Understanding, that is why, and scientist who has done this, that the name is Hofmann. So the word is Hofmann degradation, or you can say Hofmann rearrangement, you can say Hofmann bromide degradation, because here we are using bromine gas, that is why with the help of the bromine we are going to degrade the amide, that is why it is called as Hofmann bromamide degradation, Hofmann hypobromite degradation. So here, students, what will happening in the amide, students, there is a conversion of amide into the amines in the presence of bromine, that is why it is also called as Hofmann bromide degradation. And alkali is known as Hofmann degradation of amide. So what is the Hofmann degradation? The conversion of amine into amines in presence of bromine and alkali is known as Hofmann degradation of amide. What is happening, students? Amines form with one carbon less. What is the importance, students, of because of the degradation? What is happening, students? There is a one carbon less than amide. If amide is having 2 in number of carbons, so amine will have only 1. Understanding, students? So it will have only one carbon always less. There is a minus of 1 carbon. Okay, students? So this way, students, amines form with 1 carbon less than amide. There is a molecular rearrangement involves the migration of alkyl or aryl group from the carbonyl carbon to the adjacent nitrogen carbon. Okay, students? The alkyl group which is attached to the carbonyl carbon, students, this is carbonyl carbon, it will migrate and adjust to the nitrogen atom. That is why it is also called as rearrangement, Hofmann rearrangement reaction. Generally, students, we can write it here. This is the carbonyl, one valency by alkyl, other by NH2. So this is the alkyl amide, students. Amide, we are passing bromine gas in presence of aqueous KOH. So here, students, 4 molecule of KOH is required. KOH is aqueous. Now what happens, students, when you heat this mixture? So students, this carbonyl, it will break. That is why we call as degradation. Okay, students, this is the amide, students. Any amide, students, what will happen, students, when you pass bromine gas and aqueous KOH? So there is a degradation will take place, students. So this carbonyl will break, and now this carbonyl will combines with potassium, and it will gives you K2CO3. Okay, students, out of 4, now 2 have used, students. So other 2 potassium now combines with bromine, and it will gives you 2 KBr, potassium bromide. Now here 2 oxygen are there, students. They will remove as it water molecules. 2 water molecule we are getting. Okay, students. Now what happens, students? This alkyl will migrate and it will combines with the nitrogen. The alkyl now it will migrate and it will combines with nitrogen, and it will form the primary amines. So this way, students, you have got the primary amines, formation of primary amines. That is why it is also called as Hofmann rearrangement. This alkyl will migrate and it will combine with this nitrogen. It will form the primary amines. There is a formation of primary amines, students. That is, and this will have, because this carbon is removed as a carbonate, potassium carbonate. So there will be less carbon. It is having 1 carbon less. 1 carbon less. Understanding, students? Because of this degradation. So that is why this is very important reaction, students. Now we will see some example. Instead of this, students, you can take aromatic amide also. So you will get aromatic primary amines. Understanding? Carbonyl, 1 valency by, here I am taking methyl. Example, students. Now what happens, students? This is the acetamide. What happens, students, when you pass the bromine gas, which is very reactive in presence of aqueous KOH? Aqueous KOH. Now what happens, students? What will happen when you heat it, this mixture? So students, I have told there is a degradation. So this bond will break. Okay, students. Now this methyl will, now it is combined with nitrogen, and it will form the methylamine. Okay, students. So this way, students, there is a formation of methylamine. There is a formation of methylamine. This methyl, carbon of this methyl, now it will join to the nitrogen and it will form methylamine. And along with this methylamine, you are getting this carbonyl, which is degraded from here, students. Now it will combine with potassium of this potassium hydroxide, and you can remove as a potassium carbonate. 2 potassium now combines with 2 bromine, and it is removed as a KBr, potassium bromide. Now what happens students, here 2 oxygen will be removed as a water molecules, 2 water molecule will be eliminated. So this way students we have prepared the primary amines. We have prepared primary amines from acetamide. So acetamide is converted into primary amines. It's very important reaction in board examination. Sometimes they may ask action of bromine and aqueous KOH on acetamide. So this way students you have to represent the answer. This is very important students. Here it is containing 2 carbon. This acetamide is having 2 carbon, but here methylamine is having only 1 carbon. Okay students, so 1 carbon less. Understanding? 1 carbon less primary amines are formed from acetamide, from the raw material. That is why this reaction is very important students. It is also called as Hofmann degradation of amine. You can also call as Hofmann bromine, because we have used this bromine, so it is also called as Hofmann bromamide degradation. This way students you have to represent the answer in board examination. For 2 marks they may ask. So this way students you have to represent the answer. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.